Alright guys, I did get some flags from YouTube. Copyright copyright hits. So I just took the video down and went back in and re-edited, and a few of the other earlier places where I was playing the record player. I didn't think I was playing it that long, but I went ahead and I just blanked that music, some of that out. And then a little bit later on in the video, I decided I'm just going to select the audio or the music and reverse it. So in this video here, it's going to be kind of first there's going to be silence in between certain segments, and then all of a sudden there's going to be the music will play, but it's reversed. So we'll see how that works. So I just want to let you guys know that. And I'm sorry that the video was so long, but I could have broke it in half, but hey, when you work on this stuff, sometimes it's short. And, I could have broke this thing down in 3 passes. But anyway, I talk too much. I know that. But anyway, thank you for guys for watching. Thank you for your understanding. And I didn't want to get no hits, but I did. And it was funny. I'm sitting there saying, oh, I hope I don't get no hits on that. And I'll be danged. I'm sitting there playing that music. Who knew, right? Anyway, that's that. Thanks for Oh, hey everybody, there you are. Hey, welcome back to the channel. Been a little while, hasn't it? It's Monday. I officially taken off work. I got a lot of yard work to do outside. I just don't feel like it getting out there right now. It's still a little cool for me. And anyway, I thought I'd revisit this little record player, little RCA Victor. I don't remember where I left off, so I believe the power supply, rebuilt the power supply and substituted a silicon rectifier for the selenium rectifier. Of course, when I did that, I had to have a place to put the filter capacitors. I got that backwards. That's how long it's been. It had a can electrolytic, I believe, and I substituted the capacitors, the electrolytics, with externally mounted. I didn't restuff the little electrolytic cap in there. To do that though, this whole circuit for that amplifier is about that big. Didn't have enough room to put the capacitor, so I had to take the selenium out, put a little circuit board, terminal strip in there, then put my capacitors in. However, the voltages are now higher than my my capacitors are rated, or right at that voltage, and I don't like doing that. Now, I've been too cheap to just order higher capacity, higher voltage capacitors, and it's bugging me. So I'm going to take a quick look. This video may go nowhere. I may trash it. But I'm going to take another look inside this thing and see what I can do to use the existing capacitors and see if I can put that selenium back in there. Because I don't drink the Kool-Aid, oh, it's a selenium rectifier, change it. Well, they work. There's a lot more selenium rectifiers out in equipment than you think. All this test equipment behind me that uses seleniums in there in places, they're still in there. Unless it's bad, I don't change them. It's just easier to keep the seleniums in there because that's what it was designed to be for. Otherwise, you got to mod the circuit with resistors, which increases the heat. And in this little record player, there's just not enough place for that. And I could do it different ways, but anyway, with all that hot air being dispensed, let's crack this thing back open, get this circuit board back out, or this chassis back out. Let's have another look at it. And also, this time I can test the record player because I finally bought me some records. Anyway, let me pause you for a minute, change everything around. We'll get this thing opened up, and let's have another look at it. Alright, we have the chassis back out of the record player. Let's see, and I found a lot of pieces and parts. that came out of this thing, just laying in the bottom of the chassis. And I've been meaning to get a manual for this and see if I can get a breakdown view of where all those little pieces go, because somebody's messing around in this before I got it. So anyway, right here is the exactly where the amplifier chassis is, and it's what is that, about 8 inches? No, I'm sorry, 6 3/4 inches by 1.5 inches by approximately 2 1/8 inches deep. That's how big that chassis is. I'm trying to remember what I did to this thing. The second thing. This is the chassis right here. My view is upside down, which means there we go. That's the chassis right there. Here's the little preamp tube right here, and here's the output tube right here. Let's see, that's a 6AT6, and I think this is a 25L6. And there's the insides that we repaired. And this is where I have the filters right here. It's and that's where the electrolytic was right there. So I'm still trying to decide. What exactly do I want to do with this thing. Because if you've watched my channel before, you know that. Let me get this out of the package. There's the shield. That limits what you can do. Anyway, and all the other components out. Let me get all this stuff out of the way. Here is the electrolytic can. Of course, it had leads coming out of it, which I should be able to replicate that easy. So I think that's going to be my mission if I have the time to do it. It's just the way this thing is made. Yeah, I think I can do it. We may replicate that. And if I do, it's just a little selenium stack right here. There's nothing wrong with it. I think I'm going to put that back in. Here's the one of the knobs, which is, if I remember, what was that guy's name on YouTube? X-Ray Tony B, I think. He was talking about why these knobs do this, and it has a lot to do with acetic acid, which is what these things are based on. They're like, I don't remember. I'm going to have to. There was an episode he was talking about why, you know, like your older Exolite screwdrivers, had that little white film on them. You scrape it off and it come back. Well, this knob is doing the same exact thing. I know it has to do with acetic acid, but I can't remember at this moment. So anyway, let's get back to the record player. So here is the these are the screws that holds down the turntable to the inside of the cabinet. They're a little rusty. I think I might clean them up. Here are the 3 wax capacitors that were in there. See that cat light reflect? So we change all those out. Yet another screw. Spacers. I think that come out of the record changer. These are the rubber bumpers that I was using trying to get the motor, the drive motor, right in the right plane, in relation to the turntable itself. That was fun. And then here's more bits and pieces right here. I got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 of the little round-headed flat washers, I guess you call them. That goes on these screws. So that's count. Let's say I got 1, 2. How many did I count? 1, 2, 3, 4, 5, 6, 7, and I have 7 of these. So those are all accounted for, which is amazing. I believe these are the screws right here for the rectifier. It has to have an insulator in there somewhere. Alright, and then I got the 2 mystery washers, and this one here's a aftermarket washer. I got one screw that holds the chassis on, with the cover on. Okay, and then this is like a 22 ohm resistor, which probably have to go back in there. So that's where we're at on that. The thing about this capacitor, it doesn't have a lot to grab onto. Some genius cut the wires. But I guess I'm going to yeah, it calls for 80 microfarad at 150 and a 20 microfarad at 150. So let me see if I can get this open and apart, and I'll bring you back. Okay. Let's see. Pull you up a little bit where I can see that display a little better. I've been meaning to find me an external monitor for this camera that I can just set up out of the side, out of the way, and I'm cheap. But anyway, here we go. We're going to lower me. We're going to start doing the old pliers cut routine like I've shown on my videos, how to open these cans up. Just peeling it back. Just take little bites. Little bites. And of course, that's my disclaimer I need to put on here. This is all high voltage stuff. This is actually line powered equipment, which means one side of the chassis is going to be hot. So if you decide you want to take on one of these things and work on it yourself, you're doing so at your own risk. Because Sam did not tell you to open up one of these things and just jump in there willy-nilly. And like I've said before, you're doing so at your own risk. Not trying to be ugly. I'm just saying, these are high voltages. They will kill you, and you will hurt until you die. If it don't kill you, it'll make you wish you were dead, because it's going to hurt pretty bad. I've been on in between the potential sources before. In other words, I've been shocked several times in my electronics career. I wouldn't wish that on anybody. It's a horrible thing to that happens to you. And luckily, I survived. There's a story that when I used to work for Motorola years ago, I was working on a transmitter, or what they call a base station, as a two-way radio, and I had to bring it to the shop. Anyway, I had the base station in the workshop there, and had a piece of test equipment plugged into the wall, and I had a little RF cable, signal cable connected through a barrel connector. In other words, you could twist it, pull it apart, twist it, pull it on. Anyway, I grabbed those two pieces, and when I undone the BNC and pulled it apart, that thing grabbed me just like that between both arms, which meant all the current was going through my arm, through my heart, through the other arm. I was in risk of electrocution, and it had me. I finally laid over and kicked myself away from that, got it out of my hand. Meanwhile, my workmates over there thinking I was stupid. I cussed them a little bit. Anyway, come to find out, one of the guys' piece of test equipment, it was a mobile communication service analyzer, kind of like this guy right here, but it was a battery-powered unit. And but anyway, I took it apart. Why did it do that? Well, there was a toroid coil in there that was wire around for noise immunity and all this kind of stuff. Anyway, that coil had gotten close to one of the screws that, the chassis screws, and it rubbed into it. So one side of that hot side of that coil was touching that screw, and of course the guy that had the piece of test equipment cut the third wire ground off. So when the coil touched that screw, it electrified the chassis of that freaking service monitor, which made that RF line hot that I had in the base station was grounded properly. So all that current, 120 volts, went through me. Yeah, I came close to biting the bullet. Cuss the old boy says, take care of your stuff. Anyway, I digress. Back to the capacitor. Yeah, I cuss a lot. Shouldn't. Anyway, I have the capacitor ring undone. That's just what it looks like on the side. But it's an amount of price to pay for what I do. I'm sure people could have a little bit more elegant way, but this is how I do it. So now, pull the ring off. Boom. Now let's see what we can do here. Probably going to have to get the heat gun out. Hang on. Get my trusty Klein knife out. I love Klein. Alright, that's what we got to face. This thing is probably completely potted. So I'm going to pause you a minute. And I'm going to go get my gloves and get the, excuse me. I'm going to get my gloves and get my heat gun out, and we'll see if I can heat this thing up. Get this thing out of here. So I'll bring you back. I'm back. You know, this interesting thing here before I get on to this next phase of this project, I'm going to show you something. Alright, let me just get you zoomed in here a little bit. Going the right way, going the wrong way. You see my frequency counter right there? Going crazy, isn't it? Remember the episode of repairing or getting rid of the noise from my fluorescent lights? Watch this. Remember, these lights here I replaced. The ones above my bench, I replaced the LEDs. That cured a lot of my noise problems. But look, here's the LED lights right there. It's still registering. Right about 40 kilohertz. Now I'm going to turn these lights back on. I'm going to turn them off. Look. Went away. That is my main shop lights, which is 1, 2, 3, 4, 5, 6, 7, 8 4-foot bulbs on two 8-foot lamp structures. Those lights are next. But I just wanted to show you that signal is so strong that this relatively insensitive frequency counter can pick it up. Whoa, good Lord. I didn't show you today. Alright, just to show you, that's how bad this interference from these lights are. That's why, ladies and gentlemen, everything else out in this world is killing AM radio. Besides, you can get somebody 16-year-old, they don't even know what AM radio is, but I have 2 AM stations that I take care of here in Monroe. And, you know, new cars don't even have AM in them. I don't think my wife's car, which is about 2 years old, I don't think it has AM in it. It's, FCC is just, yeah. Well, I'm going out on a tangent here. We might make that a future episode. We might make a tour of my AM plants and talk about this a little more in detail. So don't let me forget, okay? All right, back to what we were doing. Anyway, here's the capacitor. I got to get us lined up properly. All right, there's the capacitor. I'm going to try. Got my gloves on. Got the heat gun. Got my fat belly. Here we go. We're going to heat this bad boy up till it explodes. I'm just trying to soften it up inside. We don't want it to explode, but I guess if it did explode, hopefully it'll just pop right out. It's going to be a little tricky. That's why I didn't restuff this, because it just looked like it liquefying a little bit. I don't know if we're gonna be successful in this or not. Oh yeah, we got some bubbles coming out of it. We got some bubbles. Move a little bit. That gives me hope. Try not to pull the wires out. Let's heat the bottom of this thing up too. Yes, ladies and gentlemen, this could be a bomb. You heat it up enough. I think it's probably got some suction on it too. Think about it. All that's in there in case you're trying to pull it out. I'm sure it's creating a suction in there, and that's probably what we're trying to pull against. Alright, here we go. See if I can grab it. Ready? I think it's still a little bit on the warm side. The gloves ain't quite made for that. Whew, that's hot. Much as I don't want to do it, I'm going to drill on the very top. I hate doing it. I might drill it on the side, a relief hole, to let some of that pressure out of it. And we'll just take the smallest drill bit I have without going to my Dremel. I hate doing this, but what do you think, side or top? I'd rather do the side. Just a little dot. There. Just a little dot on it. Help relieve that pressure on it. Well, I guess we're going to have to heat it up again. Watch, it might come squirting out of that thing. That is hot. Here we go. Well, made a little progress. Now, need a little bit tougher glove. Round 12. That is warm, buddy. Yes, sir. Ought to be a better way to do that. Very hot down there. I'm wondering if I want to go get me a Need a little bit more insulation around that glove right there. Yeah, that'll help. Try this one more time. You see me? Okay. Yeah, we pull one of them through. You can't pry on this cover. I guess what I'm going to do, I'm going to take it next door. I think I'll put it on the drill press and just drill it out. Do it the hard way. So I'll bring it back. Alright. Just got back from the workshop and managed to get it cleaned out. I don't have any physical damage. Everything's intact. It was a job. Look what was in it. Another capacitor. Still got the values and everything on it. I can't, this got messed up right here. I couldn't tell, but look at there. That's pretty slick. Basically they just took this, stuffed it in there. I may have to reuse this. The only reason why is when I put this ring back together, ring has nothing to push against. So, but what I'm going to do there is I'm going to take this right here and I'm just going to push this out. I'm going to heat this up with a heat gun again. I'm just going to take and push that out, just so I can have a barrel in here to have room to do what I need to do. So that's my next step. Alright, I'm back. Now the tube is hollow. So now, with a little bit of damage, perfectly usable. Now, any luck, should be able somehow, I may have to refrigerate this to harden it. Get this back in the case. Yep. Back in the case. So now should be able to put these rings back in there. I think I'm going to go back a 1. Now it all goes back together and I should be able to seal it tight. Might put another one in there. Let me see what it looks like. Yeah, I'll put the other one in there. Okay, there. And I'll have to find that. This is going to seal up nice. So let me clean my bench off, pull those 3 capacitors out, see if they all will fit in there. I may have to reorder another one. And we use the part maybe in tomorrow. You know how Mouser is. And the situation, this is what UPS says, the situation in Ukraine could delay shipments in the USA. Tell me how that works. What the hell does Ukraine have to do with something coming from Dallas, Texas to West Monroe, Louisiana, which should be overnight? Tell me how Ukraine even affects that. But you look on the website when you try to ship something or look at a shipping number, top of their website, it's going to tell you that crap. Anyway, I'll bring you back when I get this, figure out if this is going to work or not. Alright. I finally got to the point of the 3 capacitors. I have two 47 and 160s in parallel, which gives me what, 7, 14, 4, 8, about a little over 80, whatever, 4, 8, about 94 microfarad, but hey, do the best I can with what I have. And then a 22 at 160 right here. So now the capacitors are ready to go in to this. Which they have. Like I'm stuffing a piece of dynamite. Now, cut some of this excess lead. Let's start putting it together. Hang on a second. Put the two, I'm going to call it phenolic rings back in there. Guess I ought to test it before I do this next step, huh? Let's do that. Let's test. Let's make sure these capacitors are good and that I've got it connected right. It won't take but just a few minutes on the capacitor tester. One, warm it up. Come on, start it. There we go. Sometimes I'm not sure about my Syncor LC10. I'm sorry, my LC103. I know there's a upgrade you can do to these. Alright. So I'll tell you what I want to do. I want to put this capacitor in my little mini vise. I love my little penny vise. Excuse me. It's nice having a third hand. Anyway, we're going to do aluminum electrolytics. I don't think I need to calibrate it for that. So we're going to check the red one first, which should be, I think, we're going to check it at its rated voltage, which should be 80. Let's just check the microfarad, and then I know I'm going to check it at the voltage of 150. So let's do the volts. 150 volts. And I'm just going to do the capacitor value. Here we go. 92 microfarad. Do the leakage at 150 volts. I hadn't said it's bad yet. Let's go back and put the value in. 92 microfarad. Alright, let's check the ESR. 1.43 ohms is good. Okay, leakage is good. Microfarads test good, so we're good there. This one I think is 22 at 160, but it measures 20.7. I think it's 150 volt. Let's do the leakage. Alright. Do ESR. 1.76 ohms. Okay, we can proceed with that step. Put it back together. Okay. Ready to fill the new replacement capacitor up, or the repaired capacitor, however you want to pronounce it. Install it back in the chassis. Thing had a little hook in it, but not too worried about that. I do want the values to be where we can see them, to at least we could see our handiwork. So I'm going to rudimentary line it up. Okay, see, I'll just take my hammer and just kind of tap the sides a little bit. Get that in there a little bit more. Still in the frame? Yeah. Okay. The leads are just in the way. See if we can get this one going. Just folding the edges back around where I bent them out earlier. Get this thing apart. Oops. This thing has really been a little booty hole. Compared to them other ones. Ooh, I almost hit it too much. About deformed it. Straighten that up. Yeah. Ooh, Lord mercy. Can't go ape crap on these things, that's for sure. I'm wondering if I need to stop while I'm ahead. The leaves keep getting in my way. Alright, I think that's close enough. Let's see if we can get it back in the chassis now. So, move some of this stuff out of the way. Back over here. Let's turn that off for right now. Turn it around. Oops, idler come off, of course. Can you still see? Alright, here we go. It still needs a little work. This capacitor here was built a little different than those regular can electrolytics that don't have the leads coming out. So, okay, let's try it. Make sure I put it in the right way. See if it lines up. We'll make it work, right? Yeah, look at there. It went in. There. Got a little lean to it. I think it's fine. Yeah, that didn't have that tube in there, got a little abused that we put in there to hold that ring in place. The tube got a little bit abused and didn't really take well. I think it's good enough. May as well be. It's done, right? So now all I got to do is wire this thing back up, put that rectifier back in there and all that, clean this back up. We'll recheck it and see how it works. and go from there. So I'll bring you back. Alright, that was a major pain in the butt. Because my desoldering machine, or handheld desoldering gun, got stopped up. That was fun. But anyway, I have it rewired. I have everything back like it should be. There's electrolytics now in there. They are going everywhere they should be. Everything is in place. So what we're going to do now is I'm going to set up my measurements. Of course, this thing has an isolated ground, which is probably one reason. I gotta remember where that's at. So ground is right there. Okay. Tell you what, let me get a different test lead. Matter of fact, I'm gonna get different test leads for all this. I'm gonna plug it in, put on the variac, and see what happens. As soon as I find my test leads, wherever I did with them. Kind of lost my temper a little bit on this stupid thing. Everything I'm trying to do is not working. Now then, there's my ground. This test lead will work. Alright, I'm going to measure the main B plus, which goes straight. See if that will work. Okay, here we go. We'll have a motor in the circuit, so turn it down. Here we go. Let's see what happens. Oh, I hate that screen when it does that. Let's see if I can get you down there in both shots. You may have to squint a little bit. I'll zoom it in just ever so slightly. Well, anyway, there's the voltmeter thing. Yep. Let's turn it up, see what happens. Must have bumped it. Alright, we're at 50 volts. Already have 65, 66 volts on the DC already. So that's promising. Not drawing a lot of current. We brought it up to 70 volts. The motor started spinning. I have about 89 volts. Right there. That's good. Let's check the other side. Should be the yellow. 89 volts there. So far so good. Let's bring it up. Of course, I don't have a speaker on it. 120 volts with 100 coming in, so let's just put it rated for that voltage. 137 volts. Get back down here without popping myself. Oh, I hate Chinese made connector test leads. So the amplifier is warming up, voltage is dropping down. 93 there, so that's good. 103 there, that's good. So let's put a speaker on it. See what it sounds like. I think that's the speaker leads right there. Something. So, just notice this motor is 90 volts, 60 cycles. So you can't just pop a 110 volt motor in here. In case you didn't know. I honestly never noticed that either. Now I do. So I guess my capacitors are good. So let me get something to level this thing up with. Missing stuff. Don't know how well this thing's gonna work. That spring there is very screwed up. That volume control looks like it needs a little cleaning. I think I'm just gonna put a little bit of electrical cleaner in it. No, I'm not putting deoxit in there, because it's not an oxidation issue. It's just a dirty wiper, and if you put too harsh a chemical in there, it'll wipe out the resistive element side there, and then you won't have anything. You'll be replacing or rebuilding controls. Alright, round two. Alright, let's put the turntable back on. See if this thing will actually run. Okay, let's do 33. Let's put a record on it, see what it does. Dixieland. Well, first off, ain't got a lot of traction on that motor. There's a problem. I can hear that sound coming from that stylus. Let's try 45. Okay. Boy, ELO, I know they were getting up in age, but boy, they about slowed completely down. Alright, a couple of problems I see. Could be, I got a little noise, little AC pickup, but it could be because the shield's off. Double check on my wiring on that. It's wired exactly like it was before. So, do that, and I got to figure out what's up with this this changer part has just been so hacked by some people. It got before it even got to me. So yeah, that tone arm pressure, I'm sure, is a little bit more than required, or you know, should have. Little AC hum. I have a feeling I know what's up with that. Let's try something. Could be the line cord's not right. It acts like the chassis is hot. So what I'm going to do, take my suicide cord here. I'm going to use it to where I can reverse polarity on this polarized plug. Let's see what happens. Okay. Turn this around. Okay, well, that takes care of that. Suicide cord. Okay, so it's not a polarity thing. So on these RCAs, if you don't have everything exactly where they had it, they tend to make noise. So we got leakage somewhere. Don't want to get in trouble with the YouTube police. Alright, so the capstan does not have enough pressure on it. Basically, I think what's happening causing it to drag like that, it's just, there's a spring on there that's just been severely tortured by not me. So I got to figure out where to get a spring for this, and that should help that. So I guess in the meantime, I'm going to put the cover on this chassis, see if that helps. I don't know if it will, because it could be picking up. It could be picking up the motor, the induction from the motor. So let me try that. Okay, I have put the cover back on. Or so I guess I should call it by its proper name, right? Shield. Shield is on. So let's try it. Here we go. AC power applied. Let's see if it shorts out. Almost sound like the shield, the what do you call that? The ground cap. Something ain't right. Taking my life in my own hands, ain't I? Just for grins and wiggles. See any AC leakage between this chassis and this ground. I would say so. Yeah, there's something wrong. Yep, something wrong in the hen house, boys. So I have a tester. So let's check for leakage on that sucker. As soon as I find my test lead. I swear I had one. I knew I did. Yep, pause it while I find my cotton picking test lead for my Syncor. I know daggum well I've got one. Stupid thing was on standby. Hot diggity. Alright, we on the Syncor got this leakage probe, and we're going to probe the high side. Alright, turn the switch off. I'm so amazed with myself. High side, I was trying to remember how to do this. But check leakage. I got to set and properly calibrate it. Alright, leakage. Probe, let's see, set to 117 microamps of leakage, 0 to 800. We got about 775 microamps of leakage. So there's a problem. Something just is not connected right. I'm going to take this cover off since that made no difference. What I want to do now, turn that off. I want to make a AC, I want to make a resistance measurement. The line cord frame chassis. Well, that kind of went up and went down just really quick. Well, there's a capacitor in here. This one right here is a 0.1 microfarad, 400 volts capacitor. Get my glasses on. I can get you guys down here a little bit closer too. How about that? There you go. You can see what I'm doing, or you can see the voltmeter. It's a 0.1 microfarad, 400 volt capacitor right here from the ground to the low side of the volume control. Boy, this is taking longer than I thought it was going to take. So C6 chassis ground and common ground. It's a 0.1 microfarad. No kidding. All right, the volume control. Pin 1 of the volume control, 1 meg volume control. The ground side of it is the common ground, which, according to this, is insulated from chassis. So let's measure common ground. Alright, let me set my voltmeter up. I hate bad grounds or screwy grounds. I really do. It's either a 60 cycle hum. It's not 120. Well, in this case it's a halfway rectifier, so I guess it would be. Anyway, let's see which one of these little suckers is ground. Alright, well there we go. The ground, if y'all can even see this. So the ground comes in on the plug over here to this ground. Let's see, I'm sorry. It's a switched ground. So line cord comes in, goes through this switch right here. And that switch right there connects the pins 1 and 2. I'm sorry, 2 and 3 of V1. So all that's right. And the chassis ground, the pickup goes through the chassis ground. In other words, the shield of the pickup goes to chassis ground. Huh. So they're using chassis ground because they don't want you to touch that pickup. Cause a problem. Let me see, C6. It's piezoelectric crystal. just wonder if a selenium right here has got some kind of leakage. I mean, it's possible. I mean, I may have missed an insulator or something. I don't know. I'm going to unhook the selenium. I'm just going to unbolt it from the chassis. Maybe I'm missing an insulator. I don't know. It ain't going to hurt it to float just a little bit for a few minutes. Yeah. Everything's in place. Turn the volume control all the way up. Don't y'all hate that? Something else I want to do. Small side of the AC plug is hot. Yes, this plug is backwards. If that makes any damn difference. All right, let me go through this. I'll bring you back if there's anything to report. Alright, not that it's going to make any dang difference or not. Pretty sure it won't. We're going to recheck the isolation. Now that I've got the hot side on the going to the rectifier and the low side going to the got the low side going to the low to where it needs to go. Let the amplifier warm up. Okay, at least it don't go crazy now. And the leakage not there anymore. That's better. Put the shield back on it. Turn it off for a minute. No, I did not put a safety cap in there because that capacitor that I've got, either if it's going to blow up, it's going to blow up. But it's 400 volt rating capacitor. I ain't telling you guys not to use one. I just don't care to use them. I mean, yeah, it's admirable, but you know, to think that. You know, think, oh wow, I got a safety cap in there. Well, also have a high quality 400 volt AC cap. It should be fine. This spring right here, this big problem with this thing, just not enough, and I don't like the way it's designed. It's like something's missing. I'm tempted to go on this motor mount right here and go from there over here to the spring. It'll give it a hell of a lot more pull. I'm just wondering if something's missing out of this thing. Let's see what I can find. Well, I was digging through my junk pile and look what I found. A spring that hadn't been compromised yet. So, I'm going to take this one off. I just don't know what they were doing with that. I just don't understand. I don't understand exactly what they were doing here. I'm going to kind of ad-lib this. Just going to kind of put it where I think it ought to go. I don't know. I'm thinking it's supposed to go right here behind this little hole right here. That's where it's going to go for the moment. If it works, I'm going to leave it like that, you know. The other thing is that capstan. There we go. Oh, come on now. Be a little dirt. Turkey. I'm going to put the capstan back on. Yeah, that's not a lot either. It just needs more tension. Honestly, I want to drill a hole right there in the back of this arm. That way I'd pull it, the spring can have all the tension it can handle. It's not in the way of anything. It just don't make no sense why they done that. If I put it there, that gives me all kind of tension. I think I'm going to drill a hole in the back of that. I mean, why not? Hole ain't going to hurt nothing. Let's get out the old drill, put a hole in it, if I can. I don't know. I may have to get my Dremel. Sure my finger's out of the way. Of course, everything's going to collapse. Maybe it didn't tear up though. I really don't know. Thank you. Get out of the way. Don't know if it's a work or not. It may be in the wrong place, but we'll find out. I'm half blind nowadays. Can't see anything. I hate wearing glasses. I just get that stupid spring. There we go. Let's see what happens there. That may be too much pressure on it. Might try to back off. Alright, that stupid thing will be still. This thing might work. Not sure that's right. Yeah, tactical error. Yep. See that fallacy of my ways. Why didn't y'all tell me that? Let's try it here again. Nope, that's just not enough. Still think it needs to go back here. I really do. I gotta find what I'm looking for. Hey guys, alright. Playing around with the springs on this thing, playing the different placements, now I understand what they're trying to do. And let me unhook you here for a second, I'll show you. Get you out of here. Turning it off, screwing it up, putting my finger in the lens and stuff. But what they're trying to do with this capstan, this idler right here, is let's see if I can get you in the frame here. Sorry about that. Here's the motor. Here's the motor shaft. This is like the 3345 right here. This is 78 right here, and I'm not sure what that is. Don't know what that third second. Anyway, what this spring is trying to do right here, that spring, see that little pivot right here, this little arm? That spring is doing two things, or trying to do two things. Sorry, try to keep losing it out of frame. It's pulling this whole pivot assembly this way, but at the same time it's trying to put pressure on the idler, between the idler here and the motor. But you got to remember, this side, this part right here, is what the idler is actually turning. So now you're actually relying, believe it or not, on the friction of this rubber right here to do most of the work. And this right here is just trying to keep this pulled down like that. So I played with the spring, I've run it across here. I didn't realize then why this is doing that. It's got to be pulled out to get this in the right geometry. I think that's right. I think this spring is a little light, but the other spring was right here. You see what it's been done to it? It's been really screwed up. I'm going to have to go to Harbor Freight, see if they may have a spring selection. But in the meantime, this idler right here is fairly hard. However, it's not cracked or nothing. So what we're going to do, we're going to drop that in there, and I'm going to use something I haven't used in a long time. I'm going to use some rubber rejuvenator on this thing. And I'm going to put you back in the cradle for a minute. One day I'm going to get some good cameras if I don't hurry up and get out of this business, which retirement is looming. Okay, zoom you in. I may have to put this in my other shop, but I'm going to I've had this stuff for years. Just going to put enough in here to coat it. Ooh, that stuff smells like xylene. We'll let it soak for a while. Anyway, if you get you some of these, I think they're beakers. I'm not 100% sure. It's only been 50 years since I've been in chemistry class. But I'm just going to take that right there, and I'm going to take it over to the other shop so it don't kill me. Let it soak for a while, and I'm going to clean all this off again with some alcohol, and I'm going to re-lubricate all this stuff right here. In the meantime, I ordered a schematic, a true Howard W. Sam's PhotoFact instead of this other one that I've got, so it can get me a little bit more breakdown of how the geometry and what pieces and parts go where, hopefully. Put you over there, it's a shadow, wasn't it? Anyway, the pieces and parts and everything, and get the proper placement and make sure I got all this stuff aligned. And I'm probably just going to take all this stuff apart and give it a good cleaning and then re-lubricate it. And because, you know, it ain't like it's a half horsepower motor. It's got to be free, and it's got to be floating. And if it's not, all that drag adds up. And that could be a part of the problem too. So I'm going to give it the rubber rejuvenator, let it do its thing on the idler. I'm going to go back in and clean everything as far as all the joints, connections, and all that. But I want to do that after I get my PhotoFact. Then also I'm going to make sure I got the motor geometry right, because I had to play with all that because all that stuff was just worn out. I'm using rubber grommets that you can go buy an assortment of rubber grommets in a little box from Harbor Freight. And so I'm using that. That really, if you do it right, but I think I got the geometry right. It looks right. It ain't trying the idler ain't trying to move up and down and do all this kind of stuff. I think I got the geometry right. In other words, if you didn't have the geometry right of the motor, it would make the idler want to go up or down or something like that. I think I got that right. Anyway, I've jawed long enough. I'm going to charge the camera, let the rubber rejuvenator do its thing. I'm going to go back in here, take all that stuff apart once I get the schematic and figure out what is right and what is wrong. And once I get all that done, I'll come back and we'll see what we can play music without it sounding weird. And anyway, talk to you in a little bit. Okay. I re-lubricated some of the mechanical joints in there, and had the idler wheel sitting in rubber rejuvenator for at least a couple hours. I also put two springs in there. One, I'll put the old spring back where it came from, and I put the newer spring in there to help pull it, give it a little more pressure on the drive, on the motor drives, on the motor spindle. And so with those two things going, it is here's what I got. Telephoto in a little bit. Now we're going to try to do this without getting in trouble with YouTube. But here we go. Man, you don't even need much pressure on that stylus. You don't even need. There we go. I can hear it playing. We'll get in trouble. That's a lot of pressure on the head. I don't know if there's any adjustment for that or not. There's a spring on here. I wonder if that can be adjusted. It's got a little flat spot on that roller. that helped a little bit. Man, that is really, really tough. It puts us in 33 mode, see if it works. And no, it does not. '33 mode don't work worth a crap. It needs more spring tension this way, that's all I know, because that's what's pushing the idler out to where it would make contact. Yeah, it's definitely pulling it away. Oh man, I need new springs. Okay, let's try 33. Alright, well, what do you think, guys? Needs a little work, doesn't it? There's not a lot of torque on there at all. I mean, it stops. It should have more than that on there. I downloaded the Howard W. Sam schematic. It come with 2 schematics, a parts list, and no pictorial of the changer itself. There's absolutely no torque on this. Oh, back to the drawing board. Alright, I went ahead and took that spindle off like I was supposed to do a while ago, for the platter, and took all the lithium grease I had on there off, because lithium grease is not ideal for this. You actually have to have phono lube. I don't know why I put lithium grease on there, but phono lube is the way to go. And I use this stuff right here, which I'm almost out. I got to figure out where I got this from and get some more, but I love that applicator. Anyway, that's a real thin machine oil made for phonographs. But anyway, let's see what that did, if anything. The platter, zoom in a little bit, spins a lot more freer, even with the what's going on down there. So let's go ahead and see if it even runs. Feels better. Let's put a record on it. See what happens. And you're we'll start with his. Heard that all was nice that say. Well, wait, there is power. They have hurry up on it. Here's grabs nice tips. A lot more torque. Got something all over that knob. Alright, let's see if it got more torque. See what it sounds like now. Like a big old footprint. This record, this is a brain. Gotta get some record cleaners. Here we go. Don't sound too bad. It was nice scenery. Lugging down. Let's go to track 1, 2, 3, 4. Don't sound bad. Let's go to 5. I didn't hear any sounds of dragging. Track 6. It works now. Let's change gears on a couple of. I'm missing the E-clip to the top of the idler. That's making the idler wanting to move up and down. Like if you change it to lower or higher speed, the idler wants to stay where it's at, and it has to be able to roll over that, you know, the different graduations of speed on the spindle, on the motor spindle. So I got to find an E-clip, which means another Harbor Freight. Let's try it anyway. There's 45, 78, 45. 33. There you go, Woody Woodpecker style. What do you think? Put it back together, see how it works? I think the insides, I can do everything I need to do to the top side, so I'm thinking about putting it back in the cover, putting everything back together, and we'll see how it acts inside the cabinet. And then we'll make a determination if we need to do anything else. We do need an E-clip for sure. We need to get rid of all the rust off of hardware. Need an E-clip. I need to see if I can find some better springs. I'm trying to get the right spring tension. I think this thing will work. But it's working really good right now. It doesn't seem to have any hesitation or anything to it. Wow and flutter, if you want to say that. So let me put this thing back in the box. And matter of fact, I'm going to put my polishing wheel to that knob and see if I can make it look a little better. I will be back. All right. Let me show you the buffing wheel results. This is the one I just cleaned, which is all white and nasty. This one here was the other one. I think it's okay. So, still playing. So, just about the end of track 4. How those two are not level. Alright, let's put it back in its case. Let's see how it does. It's hot down here. I smelt my finger sizzling. Alright, been getting a minute, get set up, be right back. Okay, got this dude back together like it hasn't been in 30 years. All the screws, pretty rusted. I think I'm going to see if I can find some new ones and replace all that with new ones instead of me trying to. Something I wanted to learn, I've always wanted to learn to do is do some plating, but I hadn't done that yet, and I don't feel like I'm going to. Anyway, let's see what it does. Turn the power on, might work. Oh, look at there, the bladder still works. Amazing. 45 still works. Let's see what ELO's got to say. Hey, get up, girlfriend. See if I can find an E-clip for this thing. Call it a day on it. Maybe find another spring to replace that other funky looking one. Alright, hopefully I ain't got no YouTube strikes yet. So let me get that one off the platter. Yeah, very. Alright. Oh, that needs cleaning. Yeah, that platter needs to be resurfaced. That's pretty bad. It felt shedding. I'm not sure how to do that. I might just take all the felt off this thing and put new felt on the top. I have to look on some record player parts dealers to see if they have the kind recommended for this, or put a rubber mat on it. Might do that, but I ain't got that stuff now, so that'll be a later thing. Anyway, let's see what this one sounds like. What you think? I need an E-clip. Needs to go on here somewhere. Let's turn it off for a minute. I think that E-clip goes right there. At least I can transport it without the daggone platter falling off. Yeah, I'm going to have to don't you do it. Yeah, I'm going to have to recover this thing. Man. That E-clip just does not want to go on there. Going every daggone place but where it needs to go. Just trying to push my buttons in it. There we go. Now it won't come off. Yeah, that's what I'm going to have to do. I'm going to have to take all that felt off there. Strip it. That'll be fun. Anybody has any idea how to do that right and come back like this was instead of jury rigging it, basically? Let me know. Okay, let's put the record back in. Hopefully I can get a YouTube strike on this. What do you think? I don't really see a way to take the pressure off the tone arm. It's a little heavy if you ask me. I can hear it playing on the record itself. Don't look like nobody's been diddling around in it. They have the rest of it. Okay, so I say it's a success. We redone my previous work. We stuffed the filter capacitor can. We pulled all the guts out of it, restuffed it with the capacitors, so I could have room to put my selenium rectifier back in. Now this thing looks just like it did when it come out of the factory, other than yellow caps and not wax caps, and the filter can's a little bit gnawed on, but it's still there, and it turned out like I wanted. Selenium rectifier is still good. The other thing is the springs on the turntable mechanism. They need to be fixed, but it's working. I had to put the idler in rubber rejuvenator. That softened it up pretty good bit. Don't know how long it's going to last. What else? Clean the whatever the heck that was on that on-off volume knob. Now it looks good. Blew all kinds of dirt and crap out of the cabinet. The screws, the brass screws, I believe, and the little decorative washers, I think that's what they're called, they're pretty rusted up, and I'm going to see if I can find some replacements for it. And when I do, I'm going to get that, and I'm going to come back in on the medallion right here, see if I can get a little brass hold of that and kind of clean that medallion up a little bit, and the hinges and the plate right there where your speed indicator is, and I think this thing will be ready to go. But it works, finally. Oh, did I mention I got to get a C-clip for that, or E-clip for that idler? If I didn't say that, we got to get that too. Works really good. It was a basket case when I got it. We'll call it that. We'll call it 99.9% repaired. Good enough for this channel, right? There you go. Nice little record player. Don't know what to do with it. Anyway, that's it. Thank you guys for watching. Leave some comments on there about that felt, what I can do about that, if anything, or should I just... It's decomposing. It's all over that record. I mean, it's just going to get in those grooves and screw up everything. So I think it's pretty good. Turned out good. I love the color of this thing. So that's that. No tubes required. I replaced the line cord because they had one heck of a rigmarole in there. But it is done. Everything else is just gravy. Anyway, thanks for watching. Hit that like, subscribe if you hadn't already. And it's been a while since I had a video. Let me get that off my belly. And I think this will surpass. Like I say, I got to do a little bit of work on the platter, but on the transport, I mean the turntable mechanism. But I think one thing that helped this thing was I went ahead and got rid of that grease off that spindle. I took my alcohol pad and went back around the inside of the platter one more time. It was pretty nasty. Don't know what was on there. I thought I had done that, but apparently not. So put phono lube on there on the spindle. It seemed to spin a lot freer, as you guys saw. Rubber rejuvenated the idler. So we might be able to find a replacement. All it looks like is a square piece of rubber, a round square piece of rubber. I think we can replace that. I'm sure I can find one if I look hard enough. Otherwise, it works really good. Sounds to me like a little distorted, but I think that's the cartridge. I think the cartridge just got a little too much bias on it, and it's distorting it just a little bit. But hey, it works. So anyway, thanks for watching. Please like and subscribe. Leave any nice comments. And we'll see you on the next one. See you later, guys. Bye-bye.